Hey, Tyler from Makeoscopy here. I've got another video for you, and I think you might know what this is. It is another oscilloscope. But Tyler, I hear you say, you've already made an oscilloscope. 2, actually. No, I've made 3, because there's a third one in front of you. Ugh, get it right. Anyways, the reason I made this new one is, one, I've got this controller here, which I'll show you very soon. But when I plug that in, I'm going to play a tone. So, you can see that the tone is playing, and with this controller here, when you turn it, it slows down, and you can actually view the waveform at different speeds. So you're thinking, oh, it's only I'm playing 150 hertz. That's barely anything. Yeah, well, let's play 800 hertz. Whoa, you can see it. But look, when you slow it down, you can view it on the screen. So already we're better than my older oscilloscope. Next, let's play 1000. Whoa, you can see the 1000. I would be playing a louder sound, but I don't have a amplifier hooked up to it yet. And I also 3D printed this case with my amazing PrinterBot Simple. But finally, let's play 9000 hertz. It's over 9000, actually.
It's over 9,000!
9001 to be exact. But as you can see, it can still see it, and it looks pretty good. The fastest I got it to work at, gosh, I want to say it's like 22,000 hertz, but even then it's barely visible. A few things about this oscilloscope. Firstly, you can't really get any data value. I mean, you can get data values off of it, but you can't get like binary ones and zeros, hexadecimal, stuff like that. It does not have any triggering. This is probably the closest you're going to get to triggering. It does run off a 9-volt. I originally wanted to have this as a like a watch, but it didn't work out. I didn't have any coin cell batteries, and it just didn't work out. Plus, I don't have any surface mount components. So basically what I have in here is a Nokia screen. It's a Nokia 5110 LCD screen, 84 by 48 pixels, which it's really interesting because these standard screens are found in most home phones. Take a look at your home phone later and see if you can find it. It's got 8 pins on it, but 5 of them are for data, and then 3 are for VCC, ground, and light. So yeah, basically this runs off of a 3.3 volts, but the Arduino that I have running in here, which I ordered, it's not a regular Arduino, it's basically an Arduino micro clone, but that runs off 5 volts. So what I have to do is I have to put in the 9 volts from the battery pack, step it down to 5 volts, put it to the VIN, which is basically voltage in, I believe. And after that, I have to run the data coming from the Arduino through something called a shift leveler, or something. It's shift leveler. It's got the word shift and level in it. I'll have a link in the description and links in the instructable. That takes it from 5 volts to 3.3 volts, which then go to the data and power pins, and then you get this beautiful screen. Alright, and here's the schematic real quick. I just wanted to show you. You can see that the pins on the Arduino go to the level shifter, then the Nokia screen, the analog pin 0 goes to the voltage divider and the capacitor, and then pin 1 of the analog inputs goes to the variable resistor. For the data pins, I used pins 3, 4, 5, 6, and 7 to interface with the Nokia screen. It's a step up. I'm definitely getting better. I can't remember his name right now, and I feel really bad for it, but I'll link in the original guy who wrote the code for this. I got the code, and I modified it so that it'll work with this potentiometer here, because the potentiometer code that he's running in that is horrid. I'll link in my code on the Instructable, and if you're on YouTube, I will link in a link to the Instructable. So that is all. Thank you for watching, and like, favorite, comment, and subscribe.